So next topic is relation between F and R. What is F? Focal length. What is R? Radius of curvature. So to get this one, first we will draw the ray diagram. Okay, very simple ray diagram. You just see this one how I am drawing. Okay, this is what type of mirror is this? Concave mirror. Okay, next you have to draw what? As usual, what is this? Principal axis. Okay, now we will mark the parameters like what? This is what? C, center of curvature, and this is what? Principal focus, all these things. Now suppose I am going to draw a ray which is incidentally on this and reflecting, and one normal I am going to draw, because based on normal only we can define what? Angle of incidence and angle of reflection. So how I am drawing the normal, you just see, I am drawing through what? C. What is C? Center of curvature. And obviously this line will be what? Normal to the concave mirror. Why? This is like what? Acting like radius. Radius is always normal to that surface, right? Isn't it? That surface if you take, radius will be always normal. That's the basic concept. Now next what? I am going to draw a ray which is parallel to this and touching this surface. You have to use scale and draw properly. Okay. After this one, what will happen to this one? It will reflect. And according to the rules of this ray diagram, you know that whatever ray which is going parallel, after reflection will go through what? Principal focus. Which, see, where you studied this one? In 10th standard you have studied. Okay, the ray which is parallel to the principal axis, after reflection will go through what? Principal focus. That rule only applied. Okay, now it's very simple. This is normal. This is the normal to this one. Okay, so what is this angle is called? Angle of incidence. Okay, then it is reflecting. Whatever it is, the reflection only happening. What is this angle called? Angle of reflection. So I just marked the angle of incidence. Very simple derivation only. Angle of incidence I marked and the angle of reflection I marked. Isn't it? Next, you just name it for triangles. We have to name. Okay, so we can name it like A. This point you can call it as B. This point already we know it is pole. Okay, for this one you think about angle ABC. What is angle ABC? ABC, which is angle I. Am I correct? Similarly, angle CBF, which is what? Angle R. These two things we got. And what about these two angles? What you can say about these angles? BCF, angle BCF, which is equal to angle I. Why it is? This is called alternate angles. This angle and this angle will be same, because it is what? Alternate angles. Now look at this triangle. In triangle CBF, you can call it as this angle. This angle already I told you it is alternate angle I, and this is what? R. Isn't it? One angle is I and one angle is R. You already know what about I and R. This angle and this angle, they are always equal. This is called what? Law of reflection. So what happened to that triangle? This triangle you can say it as BCF. This BCF triangle is nothing but, you can call it as, according to the triangle property, isosceles. Isosceles triangle. Two angles are equal and their opposite sides also will be equal. Okay. So according to the triangle property, see this one, this I and R, already they are equal according to law of reflection. When the angles are equal, opposite sides also will be equal. That makes this small triangle as what? Isosceles. If isosceles triangle is there, opposite sides you can equate, no? What are the opposite sides? Angle I ke opposite, what is it? BF, which is equal to angle R ke opposite what? CF. Very simple thing. I am not using any complicated things. What you know only we used. From this triangle you got what? BF equal to CF. This is major result. Okay. Now next thing is, let the mirror is of small aperture. What do you mean by aperture? The diameter of the reflecting surface. Exactly, if you say this is what? Aperture, correct? When the mirror is of small aperture means very small. This size will be very small. What you can say about B? If it is very small, B will be almost close to what? P. Because you know physics, we are using lot of approximations. Without approximation we cannot get a result. For that sake, this B will be close to P when aperture is very small. Hope it is clear? Because when it is small, obviously B will go close to what? P. So simple thing. So I can say B is close to what? P. Okay. So that you can write FP will be almost equal to FB. What I wrote is correct. Check. This FP will be there when B is very much close to P. That means B is almost near to P. You can very well write this FP result is there. No, this FP will be almost equal to FB. Am I correct? This is the only approximation we are using here. So what we did? We are considering the aperture is very small, so that the B is very close to P. That means this FP almost equal to what? FB. Because B inga irukadu, B enga irukku po? P ki kittadha irukku. Okay. So this result is small, correct. Okay. Now what is next? If FP equal to FB, another thing, we already got this thing, BF equal to CF, right? BF is equal to CF. Then FP is equal to FB. Then what was next? One more thing, 1 second. Look at these two results. We have FB is equal to CF and FB is equal to FP. That means that what is our total CP is equal to R, which is radius of curvature. Am I correct? The total CP is equal to what? Radius of curvature. And from these two results, you know this equal to this and this result equal to this. What does it mean? When this is equal to this, what is the answer for this one? That result, FP will be what? FP is equal to, idu mottama vandu enadhu R, and this equal to this means what will be FP equal to? Total R divided by 2. This will be equal to R divided by 2. Okay? Now what is FP? FP is nothing but, what is the distance between focal length and pole? What is the distance? It is nothing but focal length, isn't it? This focus and pole, what is the distance between them? Focal length. So we can write F is equal to r by 2 or r is equal to 2f. That's all, the relation is solved. Okay. Look at the board again, very simple relation. We took a triangle which is isosceles. From that you got what? This side and this side is equal. Okay. Finally, this is close to this one. So, FP is almost equal to FB. Already we proved this and this is equal and this side is equal to this side. What does it mean? This side and this side is same. Total distance is r. Same means what? This will be what? R by 2. Okay. So, that only I wrote. FP is equal to what? R by 2. So, R is equal to what? 2F. Hope it is clear. So, this is the major relation which relates what? R and F. R is equal to 2F, provided actually there is a special condition. What is the special condition? The aperture should be small. There only we can use it. But most of the problems they will not say aperture is small. We are just using it. R equal to 2F. Clear?